I am excited to be with you guys again another week. I think this is what, week 3, something like that. So congratulations to you all for remaining faithful. I'm excited. Let's have a good and wonderful day. All right, let's jump right into it. You guys already know what I'm going for. I like to continue to show you this PowerPoint every week. So one, we're not near each other, but it helps to keep the relationship going because when you know me, you understand, you kind of know what I'm about to do. It helps us to feel connected a little bit, okay? So welcome to class. Today is math class. My name is Miss Henry. The expectations that I have for you today is number 1, set your daily goals. Number 2, find a quiet space so that you, number 3, can get focused. Number 4, have your learning materials handy. So you should have a pencil and you should have something to write on, okay? Number 5, raise your hand if you have a question. And please do ask good questions. I don't want you to feel discouraged. Don't be ashamed of questions that you may have. If this is a replay that you are watching, drop it down in the comments, and I will be sure to check those and I can still help you through that, okay? Number 6, listen to your teacher. Listen to Miss Henry as I'm speaking and teaching you. Number 7, let's have fun, all right? Let's have fun. Okay. Today is Brainbuster. What is today? Do you know? You know the month is April. The year is 2020. How cool is that? 2020. And the date is the 21st. So today is April 21st, year 2020. How are you feeling? Red, green, or yellow? Miss Henry is, let's see. I'm green today. I have to be honest with you. I stayed up all night watching TV, a series of a television show, and yeah, so I can feel it all up in here. I woke up in a good mood. I prayed for those of you that pray, and I am ready to get my day started. I want to know how you feel. Drop it down in the comments if this is a replay. If you guys want to share, just raise your hand. Okay, nobody? Cool. How will I maintain or improve my mood? Since I'm on a green, I plan to maintain my mood I prayed to feel this way, so I want to pray to try to stay this way, okay? Yep. Name the seasons. The seasons are, let's go back, I'm sorry. Name the seasons. The seasons are winter, spring, summer, fall. You got it. Winter, spring, summer, fall. All right. And what is the weather? Let's see. What is the weather? The weather is, you're absolutely correct. It is 54 degrees and the high will be 66 degrees. That's a pretty good feeling day. I see that it's going to be sunny most of the day. So if you have not been outside, I haven't been outside a whole lot. I celebrated a birthday, something like that, this past weekend. But other than that, I haven't been outside. So anytime I go outside, it's like, whoa, I feel like a new person. I get a fresh breeze of air, and I'm just excited. Feels like I've been locked up and they won't let me go. Okay. So last week we talked about, you were here last week. What did we talk about? We talked about fractions. Okay, and it's loading whenever. There we go. Okay, so fractions. You can read this with me. A common fraction is made up of a numerator and a denominator. The numerator is shown on top of a line and is the number of parts of the whole. The denominator is shown below the line, and is the number of parts by which the whole has been divided. Okay, so the numerator is on the top of the line, and the denominator is at the bottom. Let's see. Remember, one of the things that helped me to remember what the denominator is down, the word down. So they both start with a D. I kind of remember down beneath the line, and denominator is beneath the line, okay? Down denominator. And there's only two parts of the fraction that you have to remember. So you know that if you can remember what the denominator is, you can remember what the numerator is, okay? So last week, this paper may look familiar to you, okay? Here it is. This may look familiar to you. So right here, take a look of what this pink box is, what the pink shaded part is. So if we count that, we see 1, 2, 3, 4 parts, okay? So the whole number of parts is going to go at the bottom of the line. Down beneath the line is the denominator, okay? So 4. Now, we need a numerator. Our numerator is what's going to go at the top of the line. How many boxes are shaded pink? 1, 2. There are 2 boxes that are shaded pink, okay? So we should have, just as they have here, 2 over 4. 2 over 4. Let's do this one here. Right next to it. Let's count. 1, 2, 3, 4. There are 4 total parts. The total number is our whole number. So that will go down beneath the line. That is our down denominator. On top, how many boxes are shaded yellow? How many boxes are shaded yellow? 1. Where is the number 1 going to go? Well, Miss Henry, we've already filled in the denominator, so it must be the numerator. 1 is our numerator. Okay, class, excellent job. where does the numerator go? Miss Henry, you know that it goes on the top. Okay, so 1 over 4. 1 over 4. This is 1/4. 1/4. Okay? Let's do one more for review. Let's do this one for review. Okay? Here, how many parts do we see here? 1, 2, 3, 4. Right? I'm looking at where it's divided, and it looks like there are 4 parts. Oh no, Miss Henry. A fraction must have equal parts. You're right. So let me try and count that again. You guys are too good. 1, 2, 3. Miss Henry, there are 3 equal parts. You are right. So our equal parts, our total number of equal parts is our whole number. Our whole number should go where, class? Oh my God, you guys are good. It should go at the bottom of the line. So 3 is our bottom number, which is also known as our denominator. How many parts are shaded purple? How many parts are shaded purple? You got it. 1, 2, 2 parts. 2 will go at the top of the line. So our number, our final equation or our final fraction should be 2 over 3, which is also known as 2/3. You got it. So I wanted to review with you guys really quickly what our fractions, what are fractions and some of the problems that we worked through yesterday. Today I am introducing to you decimals, okay? Fractions and decimals work hand in hand. They can mean the same thing, but they are represented differently, okay? They can mean the same thing, but they are represented differently. Decimals. What is a decimal? Relating to a system of currency, weights, and measures, or other units in which the smaller units are relatable to the principal units, the overall units, as powers of 10. Again, so let me just read this other definition. A fraction whose denominator is a power of 10 and whose numerator is expressed by figures placed to the right of a decimal. So that might not make much sense to you right now, but it will. Just hang in there. A decimal is a number with one or more numbers to the right of a decimal point. Okay, so when you have decimals, you represent them with place numbers of 10, 100s, and 1000s placed, okay? Here they give us an example. This is 3 over 10. Remember I said that decimals go hand in hand with fractions. 3 over 10 is also said as 3/10. 3/10 can be written as 0.3, okay? Or 0.3, but because 0 doesn't have a place value, you can write 3/10 as 0.3, and they both are read. If it's 3/3 or if it's 0.3, they both are read as 3/10. Okay. I want to write and show you how this looks if I was to have a diagram, okay, of it. So this is 1, 2, you count. 5, 6, 7, 8, 9, 10. So there goes our bottom number, our denominator again. So anytime you are wanting to find a decimal, it's a good trick to always write it as a fraction, because a fraction is then converted to a decimal. So if you ever want to find a decimal point, or somebody might say, I would like to know the percentage of the boxes that are shaded, then you know when you hear the word percentage that you would find, that you would convert it to a decimal, okay? So we just counted this here, and this is 10 equal parts, so that means that the total number of equal parts will be our denominator. So it's 10. How many boxes are shaded red? 1, 2, 3. 3 boxes are shaded red. And this will go to the top of our line, which is also known as dun, 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 the numerator. So 3 is our numerator, 10 is our denominator, okay? So how we want to, this is what we want to do, to move, to convert this to a decimal, okay? So we did not go into division, but we did touch on multiplication. What you can do is you can divide. You can see how many times 3 will go into 10. And this is how you can determine, okay, what your decimal would be if we divide. However, I'm going to give that to you as an assignment to work at home. And I want to kind of work with you and just with the place values of a decimal. So the place values would be 10 place, the 10th place, the 100th place, and the 1000th place, okay? And those places would be represented behind the right side of the decimal. So really quickly, let's write this out. So decimals. A decimal is a number with, are you writing this down? Write this down. With a 1 or more numbers to the right of a decimal. Uh-oh. Did you catch that? Okay. Of a decimal point. Let's read that again. A decimal is a number with 1 or more numbers to the right of a decimal point. Our place values that we will have, place values will be in the 10th place. Tenths, we do have ones. 1, ones, tenths, hundreds, and thousands place, okay? So the ones place would be the number before the decimal point. The number before the decimal point. So let's see how this will actually look so that you can visualize this. The ones place would be the number before the decimal point. The tens place would be the number after the decimal point. And remember that 0 does not have a value. So you would actually write this as a percentage because it doesn't have a value. You wouldn't write it out like this. If there was 0%, you would just write 10. Or this wouldn't necessarily be wrong, but it does not have a value, so you don't have to. 0 just means 0. Even if it was 0 points, a million zeros, it will still be 0, okay? So the hundreds place, there is 2 numbers that will be behind the decimal point. And for the thousands place, it would be 3 zeros, okay? So 3 over 10 would be, here it is. Okay. 3 over 10 would be, so we already know the place value. How do we know the place value, Miss Henry? We know the place value because it tells us. The number below shows us what the place value would be, okay? So the place value here would be 10. So we know that behind the decimal point, we would have how many numbers? Take a look at our sheet right here. How many numbers is behind the decimal point? How many numbers is behind the decimal point? There is 1 number behind the decimal point, okay? Our number, let's go back here. Our number here is 3. This is our numerator. The number here tells us what percentage in that tens place we should have, okay? This one is really easy for us. So the number is 0, let's write it out, 0.3 or just 0.3. Did we get that? Okay. If the number had been right here, 3 over 100, our decimal point would be, let's take a look at our hundredths place, okay, which is 0.00. We would have 0.03. 0.03, okay? Now this is how. I know some of you may have thought that it would have been 0.30, but 0.30 is actually the same number. It's the same number as 0.3, which is what represents our tenths place, okay? Remember, 0 does not have a value. If it's on the end, 0 does not have a value, okay? 0 on the end does not have a value because 0.30 is when we're talking about decimals. 0.30 is the same as 0.3. If we look at 3 over 100 or 3 hundredths, okay, we would need to put the 0 right behind the decimal point so that we can hold the tenths place and then create the hundredths place. If 3 over 100 needs to be represented as a decimal, we need to make sure that 3 is in the 100ths place. If we put 3 in the tenths place, which is what you see here, 3 in the tenths place, it would be incorrect because we need 3 in the 100ths place. And in order to get 3, as we see right here, in the 100ths place, okay? In order to get 3 right here in the 100ths place, we must put 0 as a placeholder. We must put 0 as a placeholder, okay? 0 would be a placeholder here, the 1,000ths place. And the greater the whole number, we know that there will be even many more parts. And so even though, we'll talk about that in just 1 second. So 3 over 1,000 or 3,000 is 0. How many placeholders will we have? We know that we're going to for sure have a placeholder in the tenths place. Do we need a placeholder in the hundredths place? Yes, we do. Good job. Okay? Yes, we do. Now, we need to add 3 here. Okay? And even if we added many zeros behind that 3, it will still be represented here as 0.003. That's how we read 3,000, okay? Okay. We needed placeholders here and here. Can you see that? We needed placeholders here and here. Okay, 3,000. Let's work through this one together. You guys are doing amazing. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm sorry, I lost my spot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. So it looks different than this one, but it is still 10. Okay? How many boxes are shaded? How many boxes are shaded yellow? 1, 2, 3, 4. Okay? 1, 2, 3, 4. So we know that 10 is our bottom number, 10 is our denominator, 4 is our what is it? What is it? It is our numerator. 4 is our numerator. So the way that we say that is 4/10, okay? 4/10. So if 3 over 10 is 0.3, take a look at the sheet here. If 3 over 10 is 0.3, 0.3, if it is 0.3, that means that 4 over 10 would be 0.4. You got it. You guys are so good. Color parts of each object to match the decimals given, okay? So here, let's count how many total boxes we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if it says 0.7, if it is 0.7, how many boxes do we need to shade? 7. 7 boxes. So let's color 7 boxes. Here, can you see? Yep. 1, 2, 3, 4, 5, 6, 7. 7 shaded boxes. Okay. Here, 0.6. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. 0.6. And I have a different crayon. Okay. This is what 6 shaded boxes look like. 6 out of 10, 6 over 10, or 6/10. This is what it looks like. Now, 0.5. I don't know if you guys remember. I want to show you what half looks like as a fraction. This is what half looks like. This is 4 out of 8 boxes shaded. 4 out of 8 is also converted to a smaller fraction of 1 over 2. 1 over 2 is always represented as half. 0.5 is another one of those golden rules that always means half, okay? And so if we, if we say, Miss Henry, I don't have to count those boxes. I know that 0.5 means half. And if we don't count those boxes and we just color in half, let me show you. If we just color in half, 1, 2, 3, 4, 5. If we just color in half by looking at it, you say, now that's half. How do we know it's half? Because there's an equal number of parts that are shaded, and there are equal parts of number of boxes that are not shaded. Okay? If we want to double check our answer, let's count the total number of boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? What is half of 10? You don't know? Let's see. 1, 2, 3, 4, 5. 5 is the number of 5 is half of 10. Let's look at our fingers. How many fingers do I have up? 1, 2, 3, 4, 5. 6, 7, 8, 9, 10. I want to take away exactly half of the fingers that I have. What do I need to do? Take away 4 fingers? Is that exactly half? Or do I want to take away the entire hand? I want to take away the entire hand, okay? And my remainder is 5. So if we want to double check if something is half of a number, what we should do, okay, is divide that number by half. If we want to check it by addition, we would take that number that was given to us, which was 5, okay? And we would add it by itself. We would add it by itself. What that means is 5 plus another 5. And our answer should be equivalent to the number of boxes that we have. And it was, okay? So there is one more thing that we must do before the end of the day. How are you guys feeling about this? Are you feeling good? Are you feeling confident? Okay. Excellent job. Excellent job today. You guys participated well, and I am so super proud of you. I know your parents are excited, and I am excited for them as well. So, you know that Miss Henry likes to add something fun just to help you guys understand further about what is what you're learning. Okay, here it is. So I also encourage you while this is loading, to anytime you learn a lesson, whether it's through homeschool, or if it's even with me, Miss Henry, go to YouTube. Find something, find a song to help you memorize the lesson, okay? Here it is.
I asked my friend, which way is optimal to convert a fraction to a decimal? I gotta know now. I can't wait till later. He said divide the numerator by the denominator. So I asked, huh? Well, how can that be done? As far as I know, 2 doesn't go into 1. He said, listen, here's what you need to know. Just write a decimal point followed by a 0. And you know 2 goes into 10 5 times. Then the decimal point rises above the line. The numerator becomes a dividend. Write a decimal point and a 0 in the tens. Divide and write the decimal point in the quotient. So what happens 5 tenths are equivalent. Later on, I was hanging with my stuffed animal, showing him how to convert a fraction to a decimal. I divided the numerator by the denominator, as he sat there real quiet like a spectator. I bet he was thinking, 5 can't go into 2. But luckily for him, I knew just what to do. I said, listen, here's how it's got to go. Just write a decimal point, followed by a 0. Then 5 goes into 24 times, and the decimal point jumps up on the line. The numerator becomes a dividend. Write a decimal point and a 0 in the tens. Divide and write the decimal point in the quotient. So 2 fifths and 4 tenths are equivalent. The numerator becomes a dividend. Write a decimal point and a 0 in the tens. Divided like the decimal point in the quotient. So what happens? 5 tenths of equivalent. I had to get my homework done before this dance. I had to convert a fraction, couldn't leave it to chance. I divided the numerator by the denominator, but to my surprise, there was no remainder. I texted my friend, I don't want to be late. Can you tell me how to divide 1 by 8? She said, back to my zeros to the right of the dividend. The value will be changed. It's equivalent. I divided the two numbers and got 125. We arrived just in time to see number rock live. Numerator becomes a dividend. Divide a decimal point and a 0 in the tenth. Divide and write the decimal point in the quotient. So 2/5 and 4 tenths of equivalent. The numerator becomes a dividend. Divide a decimal point and a 0 in the tenth. Divide and write the decimal point in the quotient. So what happens? 5 tenths of equivalent.
Let me see you move. Woo! Good job. See? Learning is fun. I know you wanted more. I know you wanted more, but our time is coming to an end. You already know that number 1, you can dream big. You must dream big. Number 2, you must go hard. Number 3, you can start big. Yeah, starting small, nothing's wrong with it. But if I can start big, why not? You can be absolutely anything that you want to be, no matter the race, no matter your culture, no matter your background, okay? If I'm in the States, the United States right now, you're in the United Kingdom, you're in London, you're in Paris, France, Africa, Europe, no matter where you are, India, you can be absolutely anything that you want to be. You can be a businessman, you can be a chef, you can be a photographer. Yes, you can be a painter, whatever it is that you want to be. I cannot wait to see you guys on next week. Have an amazing, amazing day. Be intentional, review your work, learn, and I can't wait to hear from you. Bye-bye.